All right. So hello, I'm Nick Doiron. I'm going to talk about building encrypted APIs with HTTPS and I'm actually not quite sure how to pronounce this, Paillier Cryptosystem. So if you were here for the previous talk, that kind of covered some different reasons why you'd use encryption, some different algorithms, some code. This is me more about, if you're a web developer, some concepts with HTTPS. Going back to the very beginning, like what is HTTPS? But then, I promise you, if you know that, very quickly we're going to get into some really interesting stuff, like what's going on with LetsEncrypt, how can we change some settings in Apache and Nginx beyond what's in LetsEncrypt, and then some other kind of out there future stuff like quantum computing. So I'm just trying to cram all that into one talk. So about me, I am a web developer. I usually did a lot with maps. Often I work in useful things like one laptop per child. I work with one laptop per child in Uruguay. So si hay preguntas en español durante la presentación, quizás podemos hablar, but I don't know it very well. So, okay. And some other useful projects. I also do some kind of useless projects. If you've seen on Hacker News, Fortran.io or GitJK, that was like some idea that I had, and then it's a real thing. You can check it out later. So jumping right into this. So this talk is about HTTPS, and this is a really good time if you haven't been using it before to consider putting HTTPS on all of your websites. So standard HTTP, it doesn't offer any kind of encryption. And what that means is that if someone really wanted to, not even like an expert, but if someone really wanted to and was in your internet connection, they could add information into your web page. For example, if you've been on like Southwest Airlines, they might put like a banner into your web page or something like that. They might forge content on that website or intercept like a credit card number that you're sending up into the cloud. So for that reason, people have been switching over more into HTTPS. And so if someone's monitoring that connection with HTTPS, they can still see where you're going. Like if you're going to the New York Times website, they'll see nytimes.com, but they won't know what page you're going on there. So the example people usually give is if you're in like an oppressive government state. Let's not choose a country, but you're in an oppressive country, and an embarrassing article has been posted about your leader online. They know you're visiting the New York Times. They don't know which page you're visiting. So kind of the next step up from this is Tor, but we're not going to go into it. But it adds that extra level of encryption where people can't tell exactly what you're looking at, what that page says. If you log in or use your credit card number, that's all encrypted. And it also has a key system. So these keys are called certificates, and each HTTPS page has its own certificate which was issued to that company. So Google has a certificate or multiple certificates, and if your browser sees that certificate, it knows it's getting content directly from Google. If someone tried to add their own fake information into there, and they don't have access to Google's certificate, they can't fake it. Your browser will know something's wrong. Or if someone was trying to make requests for you and then act as a man in the middle, people would say, wait, this isn't being generated by the right source. And then in recent certificates, there's something called forward secrecy. I'm not a mathematician, cryptographer, or computer scientist, so I'm not sure mathematically how this is possible, but modern HTTPS has something called forward secrecy, which means if someone comes in and takes the key that exists now, they're not able to use that to go back in time and decrypt your old conversations. So the key is the certificate that you're using to communicate is continually changing over time. So this HTTPS is actually getting more secure over time. You don't know it, you're just using your web browser like normal, but it's getting more and more secure. And there are people out there who will help you with HTTPS, especially if you run a news site or a political site. They're very concerned about protecting that. And so there's this website, secureth.news, which is working specifically on some major websites that don't have it yet. So I think New York Times is one that recently fully went HTTPS only. And there's some other news sites that are still working on it. CNN definitely still does HTTP for me. I don't know why that is. Yes? Oh, okay. So my understanding, I'm not an iOS developer, but when I was looking up this forward secrecy, there was a requirement sent out to all iOS developers. If they're requesting a URL, it must be over HTTPS, and it must have this level of security of the newer algorithms. Right. So this is some way that Apple is actually mandating that people keep moving their security forward. Hold on. Is that they're saying, like, we're not going to approve apps that go around this. And there are other systems that are doing this as well. And in the future, very near future, people will know if your website doesn't use HTTPS. This top one is a Chrome Browser Developer Edition. It's going to start, instead of just using HTTP, HTTPS, which people don't really understand in the wide world, it's just going to say secure or not secure. And if it says not secure, people are going to feel uncomfortable about that. It literally just says not secure. And then Firefox is doing the same thing. If you start to enter something in the password field, it'll tell you, hey, like the person behind you can't see what you're typing, but if someone is like manipulating your Wi-Fi router, they're totally going to see your password or your credit card number. So people are going to start noticing very quickly if your website does passwords or credit cards and isn't using this. And so I was kind of panicking because I had never used an HTTPS certificate before on any of my sites, partially because it was so expensive. I'll get into that later. Also, some JavaScript won't run on sites unless they are using HTTPS. That's crypto APIs, like the JavaScript version of the previous talk, or get user media, which uses the camera. Because Chrome just internally has decided they're not going to let websites use these secure functions in JavaScript unless they're really sure it's like that website's the one that you want to be communicating with. So where do certificates come from? Like, how can you get one? So there's a bunch of people out there called certificate authorities. And what happens is, let's say that instead it was just people created their own certificates, because that seems like the most obvious one. Like, I'll create my certificate, and when you come and talk to me, we'll encrypt it using my key. But if you've never met me before, and we're just talking over the internet, you see a new website, a new certificate, you have no proof that it's not someone manipulating you. So there need to be trusted third parties that keep track of like a list, just a directory of all the guaranteed certificates. And so those are called certificate authorities. And for a long time, this was very expensive to make a deal with them. And now there's, I think the next slide is about LetsEncrypt. So there's LetsEncrypt, which is, the logo's over here if you want to Google it. And they offer a free certificate. There's just a command line utility. You go to your site, you download their code, and you can request that it update your site. And that works with Apache or Nginx sites, or they'll just give you the certificate. If you know what you're doing, which I don't, then they'll just give you the raw information, and then you can configure it. So they're not the only ones out there. They're not the only ones out there that are free, but they're very prominent right now. Just in the past year, they've grown a great deal, and they're providing lots of free, on-demand certificates. And they're working as a nonprofit with the EFF and Mozilla. Now, you might wonder, who are these other people out there? And that's like, how do we know? Basically, what the problem is that if you have your certificate and you like it, that's great. But all these other certificate authorities are trusted, like an incredible amount. So if, for example, there was a certificate authority in the country that was the dictator country, that we don't know which country it is, but if there was some dictator country and they have a certificate authority, they could compel them to create a certificate and fake it, right? Those certificate authorities are all trusted. And this has happened several times, that governments have hacked into or tried to create Google certificates, and then Google will try to warn people, don't trust that one, we didn't make it. So there's kind of this ongoing war. And then if you're interested in certificate authority drama, which who isn't, last year there were 2 companies, one in China and one in Israel, that kind of technical, created a bunch of certificates that they promised they wouldn't and backdated them as if they were all created on the same day. And then when people asked them about it, they said, oh, I don't know anything about that. And so they're very shady, and now Mozilla, Google, Apple have agreed that this year they're not going to accept any new certificates from them. They're kind of like on probation. So kind of the security of the web depends on kind of like this cabal of certificate authorities that sometimes get put on probation, sometimes get strong-armed by governments, but most of the time everything is okay. So like it seems a little bit weird, but there are people who look at this stuff all the time, and I'll also talk about some ways that you can make your site more secure against that. So yeah, I was mentioning LetsEncrypt. It took a very long time to get set up, from 2012 to 2015. So don't think I'm going to go start my own and it's going to be great. It costs them a lot to run, but they're well funded by different organizations. And in 1 year, they generated 24 million certificates. So that could be for a domain or a subdomain of a domain or things like that. But they're creating certificates for websites all over the web. So are you, as an individual, able to do it? I would think probably. Like they're targeting Apache and Nginx sites. So the way that I've been doing it on my site is I git clone from this repo. It's a Python repo. If you know a lot about this kind of stuff, you could make some changes and affect how millions of people are working on their site. So that's pretty cool. There are some limits on it. So do you have a GitHub? Do most people have a GitHub? So you probably have, my username is mapmeld. So I have mapmeld.github.io. And someone has example.github.io. So if you wanted to order a certificate that was anything.example.com, LetsEncrypt doesn't do that right now. It's a little complicated. For example, what if what if I said I own github.io? Obviously I don't. But if I said I did and they're like, prove it, I would say go to mapmeld.github.io, and they would see that I controlled that site, and they might think that I controlled all the other sites. So what I'm getting at is LetsEncrypt only limits it to what they can prove that you control. So that's a useful thing. The automatic setup only works if you run it in sudo. If you're very paranoid about running things in sudo on your server, totally understandable. There are options that you can run it without that sudo authority. It also does renewals. Again, email every few months for each site that I register, and it tells me how I'm supposed to renew it by running the same command. So probably if you can SSH into your server, clone some code, and run some different commands, you probably will be able to do this. If you're not using Apache or Nginx right now, you probably should have some kind of middleware between your server and the larger web. So I'd encourage you to do that. If you already have HTTPS somewhere, there's this really cool website, SSL Labs, where you can put in any URL, and it'll give you a letter grade. It'll tell you how good is your HTTPS. Like we talked about earlier, there are some newer features, like that forward security, changing keys. So not all HTTPS is equal, right? There are new features being created and deprecated all the time. So this site is a really good way of saying, look, I don't have time to check dozens of things. Does my site look good? So this site would look really bad. But if you use LetsEncrypt, the modern version, it'll give you an A right away. So I feel like that's in a good place. But you can always go back and check in case something new happens, some new kind of vulnerability. So I recommend that site. And so a few months ago, maybe more, I created this gist on GitHub called OverEncrypt. And it talks about going beyond the default settings that LetsEncrypt gives you and trying to make it more secure. Is this necessary? I'm not really sure. I mean, it's more of you saying, like if I have an A on that grade, what would it take for me to go up to an A+? Or like, how can I maximize my security? Or like, what settings are out there that I don't even know about that might help me in some way? So these are kind of a document that explains this, and then I'm trying to create like a command line interface. And so I'll just give you some examples of what these settings are. These are kind of like more like X-Files type things of how people secure their site. So there's a feature called OCSP stapling. So let's suppose your server gets hacked. You say, that certificate could have fallen into the wrong hands. I need to cancel and revoke that certificate. So previously, you kind of just had to like post somewhere, don't trust that one. So this is a feature where when you revoke a certificate, it'll post it publicly. And then you can use this setting called must staple, which tells the browser, every time you come to this website and you see the certificate, double check that I haven't published a revoke statement somewhere else. So this gives you a lot of power. It lets you tell the user, if their browser is smart enough to understand this, it says, look, always check that this is a certificate I'm still using before you trust it. So LetsEncrypt has all of the stuff in place. Like when you cancel, it'll post a notice somewhere on the internet. But it doesn't automatically enable this in your Apache or Nginx settings. So this is one thing that you might be interested in. There's something called certificate transparency. So these are just something that people are talking about doing right now. LetsEncrypt will publish every certificate that they issue. So people do something like say, oh, has the US government used LetsEncrypt? Yes. Has the US military used LetsEncrypt for a .mil? Yes, but then they had to revoke them because that's not allowed under various rules. But see, if in the past no one would even know that had happened and was falling through the cracks. This way, there's a public notice of everything that gets published and everything that's removed. So I mentioned before there are some websites, or there's some certificate authorities that have created bad certificates that can like let people like hack your website. If you say all of my certificates are going to be public on the web, they can see if you're, and then they receive a new certificate. They can say, wait, was this one published? And who published it? Does it look really sketchy? And then if you're monitoring your site, you can be like, wait a minute, I've never done business with those people. They shouldn't have issued that certificate. So there's kind of like being just completely transparent, I think, is something that's going to be important in like the deep nitty-gritty of how this works. Your browser will probably just know what to do, but it's just something that LetsEncrypt is doing really well. Public key pinning. This is another good example, except it can also completely brick your entire domain, so don't mess up. So it basically says this certificate is not going to change. Like, if someone says, oh, I have like Google creates their own certificates. Like they're allowed to just create certificates at will. So they'll tell you, if you come to google.com and it says this certificate was generated by the Republic of Iran, that's not us. We didn't do it. Just look at only trust certificates created by us. And so LetsEncrypt, you could do this, but it creates some problems. Every time that you renew on LetsEncrypt, it's actually creating a new certificate. So people with regular web browsers aren't going to notice that. It's not a problem. But if you say only trust this one certificate, and then 3 months later you renew it and you have a different one, everyone is going to be confused. They're not going to be able to access your website. They're not going to trust your website. So the way I've been doing this, I describe this in the over-encrypt document. If you Google LetsEncrypt, over-encrypt, you'll find this. You recommend the certificate that you're using, and you also recommend LetsEncrypt's root certificate. So that means that you say every certificate that I issue will come from LetsEncrypt. So that means that, you know, like you're kind of stuck with LetsEncrypt at that point. But it also means if someone created a faulty certificate in another place, then people will be able to identify that as a forgery. People might ask, well, what if LetsEncrypt is hacked and then your site is affected? It's like, well, then all these other tens of millions of sites will be affected. We'll all be in it together, and kind of like maybe that will work out. Like, you know, it's not your problem if every site on the internet is hacked. Like, that's not your fault. Yeah. So, yes, sure.
At what level is this defined? Is this a web server?
Oh, okay, yeah. So in your Apache, Nginx, or equivalent settings, you tell the web browser, like in a header, this is what I'm expecting. When you hash the certificate, it will look like this. Or it'll be signed by the root LetsEncrypt certificate, which looks like this. Now, if the browser is like an older browser, it might not know what you're talking about. But so it kind of depends on the server and client talking to each other about what security they might like to use. And then if you're doing the most that you can, then it should be really good. This is something that's like not something that probably most of us will be able to use, but there's a feature called Allow Preload. So a lot of government websites that use HTTPS, and Google is another example, are just hard coding their certificates into the browser. So you download Chrome, you download Firefox. If you just, let's say you were in the oppressive government country and you went to google.com for the first time and you didn't know, your computer doesn't know anything about security yet. Someone could be completely controlling your internet and blocking you from finding out the real owners of Google and manipulating that. So what these major browsers are doing, Firefox, Google Chrome, Microsoft, I think Safari as well, have all agreed there's a list of websites that are just preloaded. And if you allow yours to be preloaded, it could eventually be part of this list if it gets that big, or they might come up with some other system because we wouldn't want like 1 billion websites all hard-coded into the browser. But this is kind of like for these more like mission-critical sites where it's like we want to make sure there's no loophole. You have to talk to us using the certificate that we trust. This is the way that people are doing it. So I mentioned before, I'm working on a command line interface to make these changes automatically. Right now, there's just like a GitHub gist in Markdown that explains each of these steps and what it looks like. I had some issues, like Python bugs. I was hoping I could release like something for you guys today, but I ran into some bugs. So how am I on time? Do you know? 5. Okay. So we're going to jump into some like more future stuff, because that was like things people are talking about and using now. We're going to jump into some future stuff that people aren't really using right now, but the future is now. You could start using it and start thinking about what you could do with it. I was going to mention, sorry. So if you're using an API and it has IDs, make sure you use a service like UUID, Unique User ID. I think, is that what it stands for? UUID. Universal. Okay, thank you. So it's just a very long ID. Doesn't look very interesting, but it prevents issues like this. So there's a website that apparently ISIS is using. To register for ISIS, you sign your contract and then upload the image. You scan the image and upload it into this website, but then they go scan/1, scan/2, scan/3. So they're able to just go through and find all these people's signatures just by adding one to the URL. So convenient if you're trying to track down terrorism, but if you were doing this for good reasons, like you were doing like a nonprofit volunteer registry or something, you wouldn't want to screw up something like this. So in general, they're just design decisions you can make, just even in URLs, that can affect people's security. Okay, wait. So yeah, I think the slides are out of order. I wanted to talk about future stuff. So this is where we're going to get into the future stuff. There's something called boring SSL, which comes from Google. And what happens is OpenSSL is used most of the time for computers and servers, clients and servers to talk to each other securely. But it's really big. There's a lot of code that was written and no one really knows what it's doing in there. It's kind of like I don't know. I don't know if they're like machines that exist. Like, is there like a mechanical equivalent of like no one knows what's going on inside your car or something? Anyway, so Google has limited it to the core pieces they need called boring SSL. And they're testing out something called A New Hope, which will allow you to keep using HTTPS after quantum computers are invented. So if you are running some kind of code that you're afraid the NSA is going to make an advanced quantum computer and break your crypto, you would be interested in this. So right now it's very X-Files, Star Wars kind of talk. But if you hear on the news quantum computer was invented, then, you know, call me or call these people, actually. They know what they're doing. Yes? Weirdly, there are people making quantum computers, but they're not like fully formed. Mm-hmm. Well, like they have some basic ones, but they use a different physical properties or something. I don't fully understand. What I like to tell people is they both exist and don't exist. It's kind of ironic. Yeah. Like some exist, but they're not the kind that we're thinking about and worried about. Yeah. But yeah. So they've invented some different algorithms that will keep working after quantum computers. We think, because I mean, it's still kind of up in the air. But you could use this boring SSL and feel really superior. And then this other thing I want to talk about is homomorphic encryption. What? So this is a kind of a new development. But what if I could send you encrypted data, you could like calculate the total or do some math on it and send it back to me without you ever actually seeing the data? Like how could you add and subtract and multiply encrypted numbers? You don't even know what the numbers are. Well, mathematicians think about this stuff all the time, and they were able to figure it out. Okay, I'm not a mathematician, not a cryptographer, but there are ways that you could send like votes or medical data, exchange rates, where the server, let's say you were making an API where your client doesn't even trust you, but they want to use your service anyway. They don't want to share their data, but they want to use your service. There are ways that you can set this up where they send you the data encrypted, you work on it, send it back to them, you never see the source data. So the example I've seen is like you could have people's votes online, and then you could tally them and say, these are the vote totals for each candidate, without being able to decrypt each individual vote and say this person voted for this one. So I have a real example of this that's in Python. It's called Cryptogeofence. It doesn't use fully homomorphic encryption. It uses this other thing, Paillier Cryptosystem. But this is something in mapping we've worked on for a long time, or kind of talked about, or kind of thought was so absurd we didn't talk about it. But what if you could send me the location of your phone encrypted, and I could tell you if it was in this like area. Let's say tell you if you're in Puerto Rico or not, and send it back to you without ever knowing your location, and without me revealing my location. So both sides don't trust each other, but you still want to share, you still want to ask a question of me, but you don't want to reveal your actual location. Because people care about their location and privacy. I don't think I have a lot of time to talk about this, but there is a library called PHE for partially homomorphic encryption. So I have a website. You post a public key and some encrypted coordinates up to it. It turns them into these encrypted numbers for the latitude and longitude. And even though I don't know what the latitude and longitude are, this is my Puerto Rico bounding box here. If I calculate the distance to each edge of the box, like if I'm outside of the box over here, this is going to be like a positive difference, and this is going to be a positive difference. So I know that you're outside of the box. And if I have this distance, and this distance, one's positive and one's negative. So that means you are within that box. So the code that I actually use here is I take your latitude and longitude, encrypted, compare them to the sides, and then I could send it back to you like that, and then you'd know how far you are from my box. But let's say my box is also secure. Like, let's say if you get to the box, like you get to this campus, you win a prize. It wouldn't be fair if you ask me, oh, am I here? And it says, no, you have to go over here to win. Then you'll just go over there, or you'll fake it, or something. So I multiply each difference from up here. Okay, yeah. I multiply each difference from up here by a random amount. So you still know if you're in the box or outside the box, but you don't have a good concept of how close or far you are from each edge. So that keeps it secure. And then I just return a bunch of JSON. Okay, so that's the end. Muchas gracias. If you have any questions, English or Spanish, let's try and talk it over. But yeah, all right, thanks.